before we move on to our code generator, I just fixed this issue down here. Quite a simple one that I overlooked. Our offset here, we're setting this to 1 instead. And I don't remember what we had here before. I think it was advance or peak. We just changed it to previous, and that has pretty much solved our problem here. Because we were essentially looking at the next token and it was kind of skipping us ahead one, which we definitely don't want. So, but now we need to make our codegen class. And again, I'm going to base a lot of this on what I had in the C# version I made. But for now, essentially, we need a class for our instruction, and we need a class for opcode. And let's see what we got here. So I'm going to copy these from my other version. So const load var, store var, math operations, alloc can go for now, alloc fields can go for now. Okay, so this virtual machine approach, I know how it works in theory, but I can't 100% explain it to 100% correctness, right? You know, I'm not an expert in the field of compilers and languages and everything. I'm just playing, having fun. I kind of know what I'm doing, kind of don't know what I'm doing. But if you imagine a stack, if you know what a stack is, we're going to take our AST and we're going to say, okay, so translate this AST into a list of instructions that we can execute one by one, essentially, when our code is running. So let's say we wanted to do 1 + 1, we would essentially load a const of 1, load another const of 1, and then we would run an add operation, which would then pop those two consts off our stack, add them together, and push the result back onto the stack. And then we can then either disregard that value, or we can then run it through another operation, you know? So it's like literally a list of operations that we're just processing and doing things with. And those opcodes are what drives a lot of this logic that we want to run. So moving forward, the next thing we need is a vector of instructions. And why does it keep doing that? I don't even know what that is. And I think for now that is it. I suppose we'll have another vector of statements from our AST. And we'll just call that code. So what we're essentially going to do is we're going to have a generate function, which then takes in a std vector of statement pointers. I guess we'll just call it encode. Actually, we could do, yeah. Or just use a constructor instead. Encode. And then our generate will just be a void function. And now essentially all we're going to do is we're just going to loop over our statements. And we're going to basically generate from those. But first of all, there's one other thing I need. Do this here. Oh, actually, we need, sorry, I forgot about this bit. What was this? We need our opcode, and we're going to allow taking a void. Maybe there's a better way we can do this with polymorphism in the future. And we're going to make a little macro here for matching Var pointer. And this is just going to be dynamic class type. Like this. And essentially what we're going to do here now is we're going to call a function called emit statement. Now here, all we're going to do is match, for example, here, and just realize one thing I want to quickly check. Change this, let statement name equals blah blah blah. Yeah, like that. Okay. So we'll match here. We'll match our let statement. And then we'll basically have we need an emit expression. And then we also need an emit function, opcode, store var. So let's make those. Now let me just double check what these were doing. So emit essentially was just adding to our code pushback, new instruction, up arc. Yeah. Don't know why that's being weird. Oh, wow, we're doing it to the wrong one, sorry. Instructions, pushback, new instruction. Okay. Now, emit expression essentially was essentially doing a very similar thing to this here. So in C#, you can kind of do these switch statement matches, but we can't do this in C++. So the easiest way I figured to do it was like this way with the dynamic casts, which I think is fine to do. It's probably not the fastest, most efficient solution, but I think it works. And I wonder if we need to make that a pointer to do that. So here, now we can say, let's see, like for example, if we want to match, I forget what these are. A type would be in literal. Var lit and expression. So now, yeah, load const lit value. I believe if we turn that to that as well, and then we just do a return. And then we'll do bool literal and string literal. And then we would also need a variable one. This would be load var name. And I think we also need to handle assignment expression. And this one, we want to omit our expression on the right hand side. And then we want to omit, yeah, store var. Is that right? Okay, hold on. Assignment expression. And then we'll do another match in here. For variable. Is this right? I think this is right. And then we omit our assignment right, and then we want to store var on var name. And we have a return here as well for now. Like here in the future, we would also handle like member access expressions for like structs and things. What was that? It's gone. It's gone forever. So now we want to handle, we omit expression on the left side, omit the right side. Now we need to omit the operation. And I believe we can't do switches on strings in C++, if I remember correctly. So opcode add. Let's just set that to null pointer by default. Plus, minus, equals, not equals, greater than, less than. Yep. Let's just quickly do. Okay, so we just do this. Find op equals that. All right, why is it checking against a string? Oh no, that's right, yeah. Oh wait, yeah. Let's just do this. Op struct. Get rid of those. Undefine it, and then otherwise we'll just, yeah, we'll throw that essentially. It just keep it a little bit cleaner because of the returns and everything. Probably a bit unnecessary to do it like this, but it is what it is. So that's those. Now we need to handle our call expression. Let's see what this just gives us. We loop over our args. We want to emit the expression there, and then emit an opcode call with our call function name. And then anything else. We can't really get the type of, or maybe we should have something on here to identify these, considering we can't use like reflection or anything to get the type name. Wait, is there a way to do this? C++ get type name. Hmm. Yeah, I'm not quite sure. So let's see. Going back up, so there's the majority of our expression stuff. Where are we at here? So we got a let statement here. We need to handle a expression statement. And this one, we just make expression for that, and then not. Okay. Now we can run the codegen, and we'll also add a codegen dump function as well. Hey, how it doesn't automatically import that? I can never remember the correct import neither. One of those. Okay. So non-binary operation plus. Oh. Add a breakpoint here. Okay, that's interesting. Oh, I see what happened here. So, yeah, low cons, low bar, etc., etc. Now, it's kind of annoying because we can't see what these are. Is there a way we could do this? What we could do is hmm. Could just do a bunch of things like this if we can do that. Why can't we convert it like that? What happens if we do a static cast? Is that illegal? Else might we have else if I don't know if this is okay to do. We're just gonna try it. And it could also be a value. Just do a toString function here as well. Um, I don't know if this is even close to correct. I have no idea. Apparently not. So, what's our instruction? It's a load const. So I guess we can't do this. Um, one way to do this would be to have like I don't know, maybe like specific instruction types that we could dump. But even then, it's not exactly ideal. But maybe it would work. Let's give it a quick go with the load const one at least. So by default, let's just have this. Actually, we'll leave this here for now just to not break it. Class load. We'll go with instruction load const. Okay, and this will take a value in. Leave this as a null pointer here. Then we'll just have a virtual convert that to a string. We'll probably need the virtual destructor thing. Let's do that. And then here, where are we? So for our load const one, for example, I'll add that function. Then let's get rid of these. See if that works. Yeah, so now we got like load const 10. Okay. It's not the best way to do it, I don't think, but it's the best way I can think of right now, at least. So we'll just do a couple of these. Still const. Wait, still var, sorry. That's still const. We'll need still var. Does this one... Okay, this one just takes a name string. So we got still var. Where is that one? And we'll want a load var as well. And does that one take a name as well, right? Yep. So you could do just a more generic one, you know, like instruction with name maybe, or something like that, but at least this way we're like, they're kind of like explicitly typed. And we got add. What do you do? So I don't think the add one, yeah, it doesn't take any parameters. Call does though, does it? A good point with the, oh no, because it needs to make expressions, but call, we can do something for call, which would also be useful. Let's call it function call. And it'll have a name and num-args. Um, the only opcode call. It is indeed. Okay, let's have a look at that. Yeah, so call, load var y, load const. Why does load const look so weird? Value to string. Okay, so oh right, yeah, we need to call toString on this, right? Yeah. Or do we? Right. Oh, we already called that here. So one of them though is scoffed. Gives a 20. And that gives an x equal. So somewhere we've messed something up, I think. On a string literal. Maybe? Wait. Oh no, I think I see what's happening here. So we're loading our string const here, but we have this the closing in here, so our lexer is just slightly wrong. Let's just test this. So we just want to -1 off this, I guess. I think. Yeah, there we go. Okay. So now you can see here we have basically have a set of instructions here that we want to execute. So here, for example, we will load a const of 10 into a stack and say, just basically store it as var x. Load a variable, a constant of 20, store it as var y. Now we will load var x and var y into our stack and call add, which takes two values from the stack basically. So I'll pop both of those off our stack, call add, and then push it back onto the stack basically. And now we want to say, if we say store var here, that's going to take the result of that operation and store it on Z. If that makes sense. So we're getting somewhere. Now we will move on to the actual VM. This is the fun part, the execution, the bit where it gets really confusing. And that'll be in the next one. See you soon.